Hello, this is another video, the second video for the second lesson, and the lessons on the process of developing models in economics, including the need to make assumptions. And as I say, this is just a short video that will hopefully explain this part of theme 1, which is numbered on the specification as 1.1.1. You might find, well, I would definitely recommend that you watch this through the first time. Then once you're done with that, go and get a pen and paper and then make some notes. You can stop and start the video as and where you best see fit. But it's really important that you take some notes. So anyway, let's get straight into this then about economic models. What are they and why they're needed? Well, quite simply, you could argue the world is a highly complex place. And that's because it's composed of millions of households and firms who interact with each other. Natural disasters and the unprecedented actions of politicians and central bankers, sorry, I should say unpredictable, not unprecedented, unpredictable actions of politicians and central bankers add additional layers of complexity to the situation, which basically makes the real world pretty hard to understand. Economic models are designed to simplify the real world. They're used by economists to explain past events. More ambitiously, models can also be used to make predictions about what might happen in the future. The first step in designing an economic model is to define your question. In other words, you need to decide what it is that you want to understand, explain, or predict. For example, prior to the 2008 global financial crisis, investment banks designed economic models that were intended to make predictions concerning the likelihood that borrowers would repay or otherwise their loans and mortgages. The banks wanted these models so that they could assess the risk of lending money to people more accurately. Because banks basically don't want to make loans to people who subsequently don't repay them. That's how banks make losses. What banks want is to make loans to good borrowers who will always repay what's owed plus the interest. So, by designing these models, the banks hope to make more profit. The model helping the banks to make better lending decisions. Which customers should the banks make loans to, and which customers should the banks reject, when they approach for new lines of credit. So governments also use economic models. It's not just banks. For example, suppose that the government wants to reduce the number of people eating sugary snacks to reduce obesity or something, whatever the government wants to achieve basically. To figure out the best way of achieving its goal, the government will need to design an economic model that identifies and quantifies the most important factors that affect the demand for sugary snacks. Should the government use taxation to raise the price of sugary food? Would that be the best approach? Or should the government ban advertising on this type of product? Would that be a better way of trying to reduce obesity? The economic model will hopefully inform the government of the correct approach to use, the approach that stands the best chance of working, the approach that will create the greatest fall in the consumption of the sugary food that the politicians object about. The second step in building an economic model is to make assumptions. Assumptions are needed to simplify the real world. If a model is to work, the assumptions that underpin a model must be logical and realistic. In most cases, economic models assume that consumers will always try to maximize their utility. Utility being a fancy word used by economists to describe the pleasure gained from consuming something. So economists assume that that consumers try to spend their limited money incomes in a manner that's going to maximize their utility, or as I say, pleasure. Firms, in contrast, economic models assume that those firms are profit maximizers. They'll try to make as much profit as possible. So the tools used to build models include logical arguments, diagrams, and simple mathematics that are all based on these assumptions of the way that firms and consumers and households in general, how they're expected to behave in response to various things happening to them. A good example of a mathematical technique that's used by economic modelers is extrapolation. Simply put, extrapolation assumes that the trends of the past will carry forward into the future. Let's take an example of a brewer. Beer takes time to make. So brewers need economic models that are designed to predict beer sales a week or so into the future. They can't just respond to what sales are today and quickly make more, because there's a time lag. So they need to predict and then provide. So obviously they need an economic model that helps them to know what demand might be in the future a week or two hence. And the model helps the brewer to match supply with demand. From past experience, the brewer might know that they should know that temperature affects the sales of beer. The warmer it is, the more people drink. An economic model might formally quantify this relationship between temperature and the demand for beer. They could use some sort of correlation analysis. The things that you've done at GCSE, you could have a diagram that with a line of best fit that was correlating temperature against beer sales, and you can plot what's happened in the past and as I say, drawing a line of best fit. So the brewer can use this very simple economic model in conjunction with a weather forecast to predict the future demand for their product, which will hopefully enable the brewer to produce the right amount of beer. Not too much so that beer goes to waste, but not too little either so that potential sales are not lost because you've not been able to meet demand because you've not produced enough. So the idea being is that you use the weather forecast, you predict if it's a hot week coming up and the average temperature is 22 degrees, you pump that into your economic model, and that will tell you roughly from year to year what beer sales to expect from 22 degrees Celsius of sunny weather. By the way, that counts as sunny weather in England. Right, so let's turn our attention to the criticisms of economic models. Reliable economic models are based on good assumptions. And what I mean by good assumptions is, do the assumptions accurately describe how people behave? Are the assumptions logical? Do they make sense? If these things are true, all well and good. But if they're not true, if the assumptions are illogical and they don't really represent how people behave, the model isn't going to work well. It's going to fail to produce accurate explanations of the past, let alone reliable predictions of the future. A good example, indeed, a topical example of a model that produced inaccurate predictions was the one used by the British government to predict the likely spread of COVID-19. The government's chief medical officer, a guy called Chris Whitty, based his model around the assumption that COVID-19 would follow exactly the same infectious pattern as the 1918 flu pandemic. In my humble opinion, this was an odd decision. It was an odd assumption to assume this, because flu and coronaviruses are completely different. One of the main differences being that coronaviruses mutate far more frequently than flu viruses. The government's faulty COVID modelling or illogical assumptions, sadly led to hundreds of thousands of Britons unnecessarily losing their lives because politicians wrongly made recommendations, mostly this idea of herd immunity as a solution to COVID. It was a wrong thing to do because COVID was a rapidly mutating virus that people weren't able to develop long-lasting immunity to, making this idea of herd immunity completely illogical. So, extrapolation can also be a problem too. Extrapolation is a technique where you assume that the trends of the past will carry forward into the future, and you base your model on that fact or on that assumption. So economic models that use extrapolation will only produce reliable predictions if the trends of the past actually do carry forward into the future. Most of the time that happens. It's true. The trends of the past do carry forward into the future. Most of the time the future is like the past. Trends continue. However, sometimes the future isn't like the past. And that can cause massive problems for economic models that are based on extrapolation. Those models will produce dangerously inaccurate predictions. So-called black swans or black swan events have a nasty habit of destroying models that are based on mathematical extrapolation. A black swan is a high-impact, low-probability event. The best known example of a black swan is 9/11. On that fateful day in 2001, the Twin Towers of the World Trade Center were hit by two aircraft, which reduced the towers to rubble, and several thousand people died. Very sad. 9/11 was definitely a high impact event. It rocked the world. For a while, people were scared of flying, and airports and airlines had to radically upgrade their security protocols. So it was a high impact event. 9/11 was also a low probability event. That basically meant prior to the terror attack of 9/11, nobody was ever predicting that terrorists could possibly hijack and fly passenger aircraft into tall buildings as part of a suicide attack. No one could possibly have predicted that. So it was an extremely low probability event. People did not expect that to happen, but it happened, and it was also a high impact event. Therefore, it was a black swan. What you might ask yourself, well, where does this idea of black swans come from? Well, apparently it comes from Captain Cook, who visited Australia, and Captain Cook was from the UK, and Captain Cook had only ever seen white swans. So prior to him arriving in Australia, he expected that all swans would be white because that was his experience. And in Australia, I've never seen them myself, he unexpectedly encountered black swans. So this is where the name black swan comes from. It's an event that nobody could have possibly predicted. Anyway, going back to 9/11. Prior to 9/11, airlines expected that passenger numbers would continue to grow at the same rate as they'd done in the past, which was pretty healthily. These airlines ordered new aircraft according to what their models were telling them, which was all based on extrapolation. Many of these airlines subsequently found themselves with spare capacity and were forced out of business because they weren't able to react fast enough to this black swan event of 9/11. The final problem with economic modelling is that economists deal with people rather than with inanimate matter like magnesium strip, like your A-level chemistry teacher deals with. For me personally, people are way more interesting than strips of magnesium for all sorts of interesting reasons. Well, one of those reasons is that people, unlike inanimate objects, can react differently to the same event at different points in time. For example, I might choose to spend £1 on a Mars bar today because today I might value the Mars bar more highly than the £1 I gave up. Tomorrow, in contrast, my tastes and preferences could have changed. Tomorrow, I might reject the same offer. I'm still behaving rationally, but my behaviour's changed because my tastes and preferences have changed. And this phenomenon of people changing their mind and their preferences changing creates a huge problem for economists and for economic modelling in general. It's highly dangerous to blindly assume that my past actions are going to form a reliable indicator of my future actions. It could well be that I change my mind and my tastes and preferences develop, and I get wise and learn stuff, and I stop making stupid mistakes. So of course my future behaviour will hopefully be more enlightened and more utility maximising than my past actions, because human beings learn. Magnesium strip, in contrast, doesn't learn. It behaves exactly the same every single time. So obviously it's a lot easier to construct models in subjects like chemistry, because you're dealing with inanimate objects rather than with human beings. Okay, in winding things up, I'm quite interested in the Austrian School of Economics. Thankfully, this is now part of the syllabus. Later in the term, we'll examine the work of Friedrich von Hayek. Anyway, what I'll talk about today is another Austrian economist, Ludwig von Mises. Austrians in general, they're very hostile to the idea of economic modelling. They say that modelling is it's hubristic. So let's dig into that. So according to Mises, this is a quote from him, and I'll just read it out. Every quantity that we can observe is a historical event, a fact which cannot be fully described without specifying the time and geographical point. Economics is the study of human action, which is purposeful behaviour. No constant relations exist in the field of human action. If we determined that last year a 10-cent rise in the price of bread resulted in a 2% reduction in demand, in neoclassical terms, we measure the elasticity of demand for bread. This does not tell us what will happen this year if there's another 10-cent increase. What Mises is, to go out of the quote there, what Mises is saying here, trying to translate him, is that my past behaviour isn't a reliable guide to my future behaviour. And as I say, this is because our tastes and preferences typically change over time. And one of the main reasons for that is that we learn, and as we learn, our behaviour changes. So this year, we'll hopefully make better decisions than the ones that we made the year before, which basically means extrapolation is fraught with danger, because extrapolation assumes that you don't learn. Extrapolation assumes that people's tastes and preferences don't change. So as I say, so therefore economic models that assume that I'll behave this year in a similar manner to the way that I behaved the year before are, you could argue, misguided. They're dangerous. Okay, I hope you found this reasonably interesting. Speak to you again soon. Bye.